Hello friends, this is GoodTecher. Here I'm going to show you how to solve LeetCode coding problem, reverse integer. The problem description is that we need to reverse digits of an integer. For example, if an input number is 123, we need to return 321. If the input number is minus 123, we need to return minus 321. And our function should also return 0 when the reverse integer overflows. So here, I'm going to show the mechanism to do the reversing. So let's have an example here. 1, 2, 3. So we look at this number, we can see it's actually composed of some single digits. So it's composed of a separate parts, that is 100 digits, tens digits, and ones digits. So it's actually composed by 100 multiplied by the 100 digits number. That's 1 multiplied by 10 plus 10 multiplied by 2 and 1 multiplied by 3. And its reverse number 3 to 1 is equal to 100 multiplied by 3 and 10 multiplied by 2 and 1 multiplied by 1. So the first digit becomes the last digit, and the second digit remains the same at the second position, but the last digit becomes the first digit at the reverse number. So our mechanism to do this reverse is that we can keep divide this original number by 10, and we keep track of the remainders, and we add the remainder to the reverse value. Reverse value initiate with a 0, and we keep add the remainder to the reverse value. So I will list the 3 columns here: number, remainder, and reverse. So number at the beginning is the original input 1, 2, 3. Remainder and reverse both initiate with a 0 value, and we keep divide the original value by 10. So 1, 2, 3 divided by 10 equals to 12. 1, 2, 3 module by 10, we get 3. And we add the remainder to the previous reversed value. So previous reverse value here is 0, and we add 3 to it. And we keep divide the number by 10. So 12 divided by 10, we get 1, and 12 module by 10, we get 2. And we add the remainder to the reverse. So previous reverse number just 1 digit, but now here we need to make it to 2 digits. So previous reverse value multiplied by 10 and add the new remainder. And 1 keep divided by 10 equals to 0, and 1 module by 10 equals to 1, and previous reverse becomes 3 digits. So previous value all multiplied by 10, and we add our new remainder. So when the number reach to the 0, we finish our reverse process. And we should pay attention here. So there's an overflow occurs. So in Java and other programming languages, integer value is 32 bits. So that means it's ranged from 2 to 31 minus 1 to minus 2 to 31. So it's 2 to 31 minus 1 is the greatest number in integer value. Minus 2 to 31 is the minimum value in integer value. So we should notice that there's some slight difference between the positive range and the negative range. So negative range actually, when we do the reverse, 2 to 31, it should be 2 to 31. But 2 to 31 is greater than the largest value in the positive range, so we will get overflows. So we should pay attention to this case and handle that case. Okay, let's go back to the problem, and I will demonstrate coding in Java. So first, I will have a reverse value. So that is a final result we want to return for this problem. So reverse just start from the 0. And we see here we need to have a process to keep divide the origin number by 10. So keep divide the origin value by 10 and until it reach to 0. And we need to, when we do this division, we need to update our reversed value. We need to multiply, keep update the previous reverse value plus its remainder. So the remainder is equal to x module by 10. So this is a process to do the reverse, and we should not forget about the overflow cases. So for overflow cases, so how can we handle that overflow cases? So every time we keep updating the reverse, so if it's not overflowed, so our newest reversed should, when it divided by 10, should get the previous reverse value. So we need to have a temporary variable to store the newest reversed value, and we will use the temporary temp variable to check whether it's overflow. So if the temp value divided by 10 equals to the previous reverse value. If it is not equals to the reverse value, we need to just return 0. So get overflows. If it just passes overflow check and the number does not overflow, we should update our reverse value to the native reverse value. Okay, we should finish our code. And before we submit the code, let's have a quick check. We use some origin input to work through this process. So let's assume x is equal to 1 to 3. So x is equals to 1 to 3. So the term first is just a remainder. That's 3, and 3 divided by 10 should be 0. It equals to the 0. So we'll pass this check, and we update the reverse to the 3, and x keep divided by 10 get 12. So next time our reverse get update and add the newest remainder. That's 2, and 2 divided by 10 equals to the previous reverse. So the 10, that's a 32 divided by 10, that's a 3 to the previous. So we will keep update our reverse. So we get 32 for the newest reverse, and x is equal to the 1, and next time we keep add a digit to the reverse. So that's 3 to 1. 3 to 1 divided by 10 is equal to the previous reverse, that's 32. So pass the check, and reverse get update to the 3 to 1. And the x keep divided by 10 get 0. So it reach to the 0. We jump out of this while loop and we return the reverse. Okay, so we should get a correct answer. So let's click the submit button. Judging. Okay, the solution get accepted. That means our solution is correct. Okay, so this is a process to solve this problem. So you should pay attention to the overflow and do the reverse. So thank you for watching this video. So I hope you learn the solution to solve this problem. And thank you very much for watching this video. And if you have any suggestions or comments, just leave the comments under this video. I will keep improve the video tutorial. This is a GoodTecher. Thank you for watching. Bye.